So one more day at 4.4. Today, though, we're going to graph tangent and cotangent. All right. So the one special thing about tangent and cotangent is that if you look at your unit circle, it doesn't take it all the way around before it starts repeating. You know how we said our normal period is 2 pi? For tangent and cotangent, you'll notice the top half and the bottom half are exactly the same. So it's only a period of pi that we're going to use. Okay? So, period 4. Tan and cotangent, use pi over b. So before we did 2 pi over b, now it's just pi over b for these two. All right, so here's the easiest way. We'll start again saying y equals the tangent of theta. All right, when we graph it, here's my graph, just like we've been doing all week, right? So let's talk about tangent. Tangent at 0, sine over cosine is 0. Tangent at pi over 2, sine over cosine is 1 over 0, so it's undefined, which means we put in asymptote. And then at pi, which would be the end of one period, it is at 0, right? Sine over cosine. So here's how tangent graphs. Remember, you always have to approach your asymptote. So from this 0, you approach the asymptote this way. And from this 0, you approach the asymptote this way. So technically, if you were doing 2 periods of it, you'll notice that if I come out here to 3 pi over 2, which would be an asymptote again, because again it repeats, and out here at 2 pi, it is at 0, you'll notice this one approaches this asymptote, and this one approaches this asymptote. So it's just a wave that actually attaches together, that kind of curves. It almost looks like one of our cubic functions, doesn't it? How it waves through. That's really what it is over and over and over again. Okay? So, although the period is only 1 pi, because it is such a short graph, I want you to graph 2 periods worth today. Okay? Does that make sense? So you'll get a whole, like, one full wave of tan, and then 2 little pieces in the corners. Does that work? Okay. So let's talk about how does it change it if I put an amplitude in the front? If the amplitude was a fraction, that means we compress it, right? So instead of, go back up here for a second, instead of it curving, it's going to be more along the x-axis before it curves up. So when we graph this one, again, I'm going to go out here and mark my 2 pi, pi. My dashes in the middle are going to be my asymptotes. Right? I know at tangent, my zeros fall here. So again, it's kind of like we have 5 points again, right? A point at the beginning, a point at the end of the second period, point in the middle, and then asymptotes fall in between each of those. All right? Then again, this time, though, because it's compressed down, instead of it curving up, it's going to be a little closer before it sneaks up. Same thing here, coming this direction. It's going to be a little closer before it goes up. It's just been pushed down, a little flatter to the line. Same thing this way. And then, of course, I go back to this one. Whoops. And down that way. So let's try one with a little bit different period in there. Let's do it. Let's say we have y equals tangent of theta over 4. Sounds good. So this time we take pi to find our period, pi and divide by 1/4. So it would be 4 pi, right? So on our graph, just like before, we know we have a beginning at 0. A middle is going to be at 0, technically the end of one period, so that would be at 4 pi. And I want you to come out here and do a second one. You guys still good? Halfway in between there, we're going to put an asymptote. Halfway in between 4 pi and what would be 8 pi, I'm going to put an asymptote. I start at 0 and approach the asymptote. Same thing here. Now, if you can draw it doing the S, you can do that, or I always have to start at 0 and approach both ways to draw it, but we can do it the other way if you want. So it's just a little more spread out across. Questions at all? Right, it'd get closer together. Or it'd be more, the amplitude part, it'd be more like a flatter line. Yeah. Any questions before we go to cotangent? Right. Yes. If the bigger the number, the less of a curve it's going to be, because it's kind of like you're pulling that line up and stretching it. So if this was like a 2 or 3 in front, it'd be more up, farther away from the x-axis as you go up. Okay? All right, let's try a cotangent one. Cotangent. Oops. All right, so I'm going to put my pi there. Cotangent works the same way. One period is only pi. All right, now, think about your unit circle. At 0, cosine over sine is undefined. So this time we have an asymptote on the y-axis. At pi, right, again, cosine over sine is undefined. And so then if we want to come out here, we can put 1 at 2 pi. Obviously in the middle is where our zeros are. At pi over 2, this is where cosine would be 0 and sine would be 1, right? At 3 pi over 2, again, this is where cosine would be 0 and sine would be 1. So now how does this approach the asymptotes this way? This is a reflection of tangent, right? So instead of it approaching this way, we've got to go to the left on top and to the right on the bottom. So back to this 0, again, it's to the left on top, to the right on the bottom. Right? When we did tangent, we went from the bottom one, we went to the left. So it's just opposite. It's a reflection of it. No, not at all. Okay. All right, let's do one more like this, and then I'll go on to the next thing I want to talk about. So I want you guys to have time to get this done so you can get a 3-day weekend. Okay? No, none at all. None at all. He wants everybody to relax, recoup, and not get together. Yeah. Yeah, it's like a snow day. So let's go with cotangent of 2 theta. All right, so if we're talking about the period this time, we take pi and divide by the number in front of theta, which is 2. So our period is only a half a pi. So here is my graph. Here's pi over 2, which means 2 periods would be pi, right? On the y-axis, we have an asymptote. On our end of our first period, we have an asymptote. And at pi, we have an asymptote. Halfway between there is our zeros for cotangent. So again, from here, on the top we approach to the left, on the bottom we approach to the right. Going back to the 0, on the top we approach to the left, on the bottom we approach to the right.
So like by knowing the period, like that's how you know like that will be the middle, like one and then.
Yeah, that's what I would, because you can do, especially for cotangent, since it starts at an asymptote and the end of the period is at an asymptote, you can do those two first. Draw this in the middle and then just repeat it a second time, if that's easier for you.
Well, the last one we did, it was pi that was in the middle because that's what it was. So then this one, we knew the period was pi over 2.
Right.
So I was just like wondering if that was the only to look at.
That's, yeah, because that's, when you get your period for tangent and cotangent, right, I always put that like right in the middle and say, okay, this is one period I have here. And then I like double that from my second period so I can draw the curve twice. Yeah, that's just the easiest way to do it. If you only wanted to do one period, it really is just as easy because you're just putting, you know, your two asymptotes and cotangent stuck in the middle. It's just the reason we do two periods is because tangent, it's so pieced apart that it looks funny without doing a second one. You know what I mean? All right, so we're good here? All right. On your worksheet, the second section is, of course, finding all that other wonderful stuff like we did before. I don't think we need to review that again. So the next thing I want to talk about is the only last thing that's new, is finding exact values of trig functions. So here's what I want to talk about. It's going to say to solve the equation. And you're going to be given something like, solve the equation from 0 to 2 pi, we'll say. Okay? And you're going to be given something like sine theta or x equals 0.75. You can't look at your unit circle. It's a decimal. It doesn't work that way. So what I need you to do is we're going to graph it. We're going to graph it in our graphing calculator. How I want you to do it is I want you to take this side and put that into y1, and then I want you to take this side and put that into y2. Okay? Yeah, sine x. So in your first y, you're going to put sine x. Make sure you're in radian mode. The second y, you're going to put in 0.75. I'm going to ask you to go to your window, and for the x values, I want you to go from 0, because again, that's where we're starting at, to 2 pi for your x values. They changed the colors? Oh, yeah. Yeah, when you go to window, go to your x values. Your x min is going to be 0. And your x max is going to be 2 pi. And it'll automatically change it to a decimal. For the y, I like to go from negative 5 to positive 5, just so that I get a bigger picture in the window. But you don't have to. So then when you hit graph, what should happen is you are going to get your sine wave. It's going to stop right here. Wow. And then the y2 creates a horizontal line going across at 0.75. All right, so here's what we need to find. We need where this intersects here, and we need where it intersects here. Okay? To do that, we're going to go second and the trace button and down to intersection. Let me get caught up. I apologize. I thought we had it. Okay. So then you go second and trace down to intersect. That's as far as I had gotten. And then hit enter. You'll see that your cursor is flashing, and underneath it says first curve. You want to make sure that it should be on your sine curve somewhere. You want to move it to the left so it's kind of close to where the intersection point is. Okay? Then you hit enter. It should say second curve. You move it towards this end, so the second cursor is flashing here. You hit enter. All right, it says then guess, and we know guess means it's thinking, so hit enter one more time. It'll tell you your first intersection point right here is at 0.848. Correct. So now we're going to repeat the same process, but we're going to move our cursors over here on first curve and second curve. So we have, again, you're going to go second, trace, down to intersection, and hit enter. First curve, you're going to make sure you're close to the intersection point you want. Hit enter. Second curve, again, you want to be close to the intersection point you want. Hit enter, and hit enter one more time. Thank you. Okay? All I'm asking you to do for some of them today is we're going to graph them and find the intersection points. All right? So, one more thing. When we graph, we did sine, which was easy to type in. Cosine is easy to type in. Tangent is easy to type in, right? Yeah, let's do a secant one. So if I want to find the intersection of secant, x equals, let's go with 1.45. When we put secant x in, how do we have to put that into our y equals? Yep, 1 over cosine x. Then in the second y equals, you're going to put 1.45. Hold on, let me get the picture up here. All right, so this picture in your graph, this picture, of course, you have this piece that's right here, and then you have this piece over here, and you have one down here, right? And you should have two intersection points. One over here and one over here. Do you see them both? Okay, that's what we need to find. So I'm going to have you go second and trace, down to intersection. Hit enter. Now, to get to that curve, if you're not on the right curve, you've got to push to the left, and it'll jump to where you need to go. So for the first one, I got 0.809. All right, let's do the second one and make sure we get how to do it, right? So, second, trace. Back down to intersection again. This time I need to get to the other curve, so I've got to push to the left. It's got to go a ways. Or, sorry, push to the right, my bad. I said that wrong. All right. Oh, yeah. Yeah, it's just, yeah, it's fine. All right, so in this one I got 5.473. Okay. No. No, as long as you're close. And then when it says guess, it goes straight to there and they, like, meet. So it works. Okay? Any questions?